Hi, this is Nathan Tintle. In this learning goal video, we are going to discuss how to compute a confidence interval for a proportion using a theory-based approach. We will use the Affordable Care Act data to talk about this learning goal. We've seen other approaches for computing a confidence interval on a proportion. We can test many null hypothesis values. This is kind of tedious, but really helps us understand that a confidence interval is a range of plausible values. We've talked about the two-standard deviation approach. This is sort of a quick and rough approximation for only a 95% confidence interval. We can't get other confidence levels from that. We're going to talk now about a third approach called a theory-based approach to computing confidence intervals. Now, the advantage is this works at all kinds of confidence levels, but it does come with certain validity conditions that must be met. Remember that a confidence interval can be thought of as a statistic plus or minus the margin of error. More specifically, we can think of the confidence interval as a statistic plus or minus some number called a multiplier times the standard deviation of the statistics. Now, the theory-based approach predicts the standard deviation of the statistics. That value is known as the standard error. And in this case, that prediction is the square root of the sample proportion times 1 minus the sample proportion divided by the sample size. While we can compute the standard error directly with that formula, it does leave the question of what's the multiplier? Well, the multiplier is related to our confidence level. We show you a few specific values here. You see the multiplier for 95% is pretty close to 2, and that should make sense because it was 2 for our sort of quick and dirty approach. It's 1.96 when we're a little bit more precise, and you'll see that that multiplier gets larger at 99% confidence and smaller at 90% confidence. So if we wanted to find a 95% confidence interval, we could use this formula. The statistic, 69% of people in the sample say that they are not affected by the Affordable Care Act, plus or minus our multiplier, 1.96, times the standard error, and that's the equation for the standard error. That gives us a confidence interval of 66.2% to 71.8%. Now the good news is, while that formula isn't terribly complicated, there's a fair number of things going on. The theory-based applet will do this quickly and easily. You can see here that you can enter your data in here on the left side, sample size, and then you can either enter in the count, or in this case the sample proportion, 69%. Click on confidence interval, and it will immediately compute the confidence interval for you at whatever confidence level you want. In this case, they've done exactly what we just showed you on the previous slide. Caution here, there are validity conditions. This is a predicted 95% confidence interval. The conditions are the same as for the one proportion test. You should have at least 10 successes and at least 10 failures in the sample. We're good here because we have 713 people in the sample who said no effect, 321 people who said there was an effect. Both those numbers are well above 10, so our theory-based approach to getting a confidence interval is just fine. A couple of final cautions. The theory-based applet is a shortcut to different confidence levels, so don't feel like you need to figure all that stuff out by hand. In fact, we didn't give you all of the possible multipliers, but the theory-based applet can get those for you and just show you the end result, which is what the confidence interval is. And finally, don't forget that validity conditions are needed for these theory-based approaches.